according to the Dalton, we have gone with the diagnosis and we are going with entirely with biology. Let us go with the chemistry part also. According, right?
Yeah.
So according to John Dalton, the name was given by Democritus in 18th century. In 19th century, John Dalton wants to establish that particular doctrine, and he has given some postulates. The postulates are nothing but proved statements. What he proved it, so for every element, if it is pure, for every element, so 118 elements are present. So these 118 elements, if you have taken iron element, the iron element breaks into simpler substances or simpler particles which cannot be divided further. So that indivisible particles, which the name already given by Democritus, and this John Dalton has said that these particles are indivisible, which cannot be divided further. That smallest part of that ion gives the entire properties of that iron element, even with the mass and even with the physical and even with the chemical properties. Understood? Yes or no?
Yeah,
but you have a doubt, Neha?
no, ma'am, I don't understand.
You did not understand?
No, ma'am, I told I understood.
Yes, just text it here, just text it. Okay, Neha, thank you. So in that sense, but there are some drawbacks with John Dalton also. So he has given all the proved statement, almost all the proved statement, like 5 to 6 statements he has given. That 6 statements, almost all are correct. But one statement gives, it gives what we can say, the description of that statement is not correct and it was proved by the remaining further scientists. So what is that main drawback? According to Dalton, what he said, the smallest particle of any element is considered as atom, and which cannot be divided further. They are indivisible. That means other than this atom, no other smallest particles are present in it. Understood? But this was proved wrong in the sense that statement is correct, but did not give the further explanation. But further doctrine was concluded by the coming up scientists. What they have concluded? So atom is indivisible, but what about the subatomic particles? What about the subatomic particles? What are subatomic particles? Protons, electrons, neutrons. Understood? Protons, electrons and neutrons, all the three. Understood, children? So this subatomic particles were not explained, were not given any explanation by Dalton. So that's why it's considered as a bit drawback, limitation. But the statements, all the statements what he has given, even now we are following it. That means they are proved statements in 19th century itself. Understood? So here I can say that here 3 elements are present. This is copper, gold and silver. This is copper, gold and silver. If copper breaks, we'll get only copper atoms. No other atoms are present. The smallest piece of copper, that atom gives the entire property of copper. And even in the mass, density, atomic, what we can say density, physical properties and chemical properties. So how will the blood sample will give the entire property of body? Few amount of sample, they can diagnose more than 5 to 6 diagnose test. Even though if they want to take 20 also, they'll take limited only, like 3 to 5 ml. The highest is like 5 ml they'll take. But not much more than that. Understood? So the gold consists of gold atoms. Silver consists of silver atoms. Any doubts? Any doubts, children?
No doubts.
This is about the matter is made up of the smallest particles. They are nothing but atoms, which was given by the scientist John Dalton at 18th century. In 19th century. So this is about what is the matter. Matter is made up of particles. So till here it is clear.
Ma'am, matter is made up of. Please repeat that sentence. I haven't heard it.
Matter is made up of the smallest particles, or matter is made up of atoms. So atoms means indivisible particles. Atoms means indivisible particles which cannot be divided.
Ma'am, even molecules.
Molecules are different here. Just I am going to the next slide. So we are talking about element and atom. Element, 118 elements are there. The smallest part of element is atom only. That is completely different. Understood? Element and atom. When we considered molecules, molecules are the smallest part of compounds. You understood what I said? Yes? Molecules are the...
Ma'am, please tell what molecules is again.
Yeah. Yes, pardon?
Ma'am, please tell what molecules is again.
Game? I don't know. What game is that?
Ma'am, I'm saying that. She's saying that. Can you please repeat the definition of molecules again?
Again, sorry. I thought that you have asked about any game regarding these molecules. Okay, the smallest part of compounds are molecules.
Then what are atoms, ma'am?
Atoms are the smallest particles of elements. Elements consist of only one kind of atoms. Compound is a combination of different. Water is a compound. It's a combination of
it's heterogeneous. A compound is heterogeneous.
No, they are not heterogeneous. They are also homogeneous. Why
no,
they are
heterogeneous? Ma'am, mixtures are heterogeneous, but can be heterogeneous or homogeneous. But ma'am, compounds are homogeneous because they are in a fixed proportion.
Fixed proportion, and though they are in a combination of different atoms, they show single property. Water shows single property only. We can't separate hydrogen and oxygen physical properties.
Ma'am, is iron sulfide an example of a compound?
Yes, sulfide is an example of compound. Yes. Yes. Iron sulfide, acids, compounds, glucose, carbohydrates, all these comes under compounds only. In fixed proportions, though they are combination of different atoms, they are homogeneous and they show only single property.
Ma'am, it's not clear for me why water is a compound.
Compound means what? It is a combination of two or more different elements combined chemically and shows only one single property. There in water, hydrogen and oxygen is there. Both hydrogen and oxygen combine to give water. There hydrogen won't show its own property, oxygen won't show its own property. The both shows the property of water only. For example, the same hydrogen is present in acid also, HCl, hydrochloric acid. But there that hydrogen acts like acid and here the hydrogen acts like water, neutral. That means when they combine with the other elements chemically, they form a different product. That product shows the single property. Understood, Neha?
Yes, ma'am.
Is it clear or shall let me explain once again?
No need, ma'am.
Yeah. So hydrogen here we can see hydrogen diatomic molecules. When single hydrogen is there, we called it as element. When two hydrogens in the atmosphere itself, single hydrogens won't be present because they are diatomic. So these single hydrogens combine chemically by their own, like covalent bonding. They'll undergo covalent bonding. They'll combine chemically. They form hydrogen gas. Hydrogen H2 is considered gas. Hydrogen single H is considered as element. Understood? At the same way, nitrogen N2, oxygen O2, fluorine F2, all these are gases, children. And this is a liquid and this is a solid. Fluorine Cl2, bromine Br2, and iodine I2. So we can see that the single white single white is considered as hydrogen. Two hydrogen elements atoms combine to form hydrogen gas. Here also. So like this they combine. Once they combine, they form a separate product, and that entire product shows the single property. Okay, many water molecule, many water compounds are present in a tumbler containing water. But the smallest part of that compound is nothing but molecule. Molecule is a combination of that particular unit. Understood? Yes?
Ma'am, can you please tell me what is bromine?
Bromine okay.
Ma'am, your voice is breaking a lot. Ma'am, your voice is breaking a lot.
Yeah, just log out and log in.
Yes, ma'am.
Okay, so we can observe it here. I'm showing this is the like a sketch of periodic table. You can see that how that metals and non-metals are present in it. Just that we are going to learn further concepts. Okay. Well, these are atomic, monoatomic, triadic. All these are also we are going to learn now. Any doubts regarding element, atom, compound, molecule?
I didn't understand the second elements that exist on as polatomic molecules.
Atomic in the sense, atomicity, especially atomicity in the sense, the elements which in the periodic table, they are like simple alphabets. Simple alphabets, that's why homogeneous and they are very pure. So these elements have tendency in the atmosphere spontaneously on their own. They combine with the other elements to form like hydrogen in the atmosphere. It won't available like H. It is always available in the form of H2 only. Then it is two atoms of hydrogen. No, it comes under diatomic. Understood? Understood?
No, ma'am.
So hydrogen. I'm just sharing the screen. Sorry, starting my web. Let's see. I'll just explain you on the board so that it's you'll be having some clarity. I think so.
Now it's not visible. Yeah, now it's coming. No, it's turning and turning. Yeah, now it's visible.
Yeah. So the atomicity means number of atoms in the molecule. So monoatomic means they always in single, they won't combine with its own element. Like helium, they are inert. Helium in the atmosphere, it is present like He only, and even in the periodic table also He only. Why? Because they are considered as monoatomic, they won't combine with the other atoms, similar atoms or any other atom. Okay, like sodium. Sodium is also mono. Mono means single atom is present. Understood? Neha?
Yeah, ma'am, that means they won't combine with any other atoms.
It won't combine with any other atoms or its own atoms also.
Yes, ma'am, understood.
So here hydrogen is always, sodium is always with Na. Na2 won't be there. Na2 won't be there. Because it is monoatomic. When it comes to the diatomic, when it comes to the diatomic, they always in the form of combined, like two atoms. How many hydrogens? Two hydrogens. How many atoms? Two atoms. So this atomicity is 2. They always in the form of H2 only in the atmosphere. The nitrogen also.
Ma'am, there also could be H2O.
That is different. Let me go with slowly. Just understand. Then H2O.
Ma'am, can I answer Neha's question about H2?
Wait. So diatomic means wait here like 2 minutes. Let me complete this because there is a problem with the audio and video also. Let's go with slowly. Don't interrupt. Okay? I think you'll understand. You are very good children. No? So diatomic means H2, N2, O2 and Cl2. That means 2 atoms of hydrogen, 2 atoms of nitrogen, 2 atoms of oxygen, 2 atoms of chlorine. In general, it is present in the atmosphere like that. They won't be like hydrogen, oxygen, they won't be like that. Single oxygen won't be present in the atmosphere. If single oxygen is present, it search with the other oxygen and they combine covalently and to form O2. That O2 only we inhale. We can't inhale single O. That's why they consider di means 2. Di means 2. Any doubts? Any doubts?
No, ma'am.
So now let us see about the triatomic. Triatomic. So here one more thing, Neha, that you can understand what you have asked. Diatomic can be same atoms or different atoms. HCl. This is a molecule. It's a one hydrogen and one chlorine. 2. So it is diatomic. Diatomic can be of same elements combining with each other or with different atoms also. Sodium 1, chlorine 1. So both together 2. It is also comes under diatomic. Understand?
No, yeah, this
Understand?
is ma'am, I understood this, but that H2O could be diatomic.
H2O comes under next is tri means 3. More than poly means many.
Ma'am, H2O is also a compound, ma'am.
H2O also compound means when they combine to give one
Yes,
product.
ma'am, because it has hydrogen also and oxygen also.
Yes. How many hydrogens are there? 2 hydrogens
Ma'am,
and
2 hydrogen.
Ma'am,
2 hydrogen and 1 oxygen.
Yeah, ma'am.
Is it clear?